Geometry of molecules. VCPR theory explain the geometry or shape of some simple molecules. First category is central atom containing no lone pairs. So first let us take first molecule type is AB2. Okay, A represents the central atom and B represents the surrounding atom, and it contains two electron pairs are present, so it contains two covalent bonds, and the molecular geometry will be like this: linear. It is linear in shape, and the angle between them is BAB angle is 180 degree. Examples are carbon dioxide, BeCl2, HgCl2. All these are AB2 type. Second type is AB3, and it contains 3 electron pairs. So 3 bonds are present, 3 AB bonds are present, and all the angles AB angles are 120 degree, and the molecular geometry is trigonal planar. Examples are BF3, AlCl3, etc. Next, third molecule type is AB4, and it contains 4 number of electron pairs, and it contains 4 AB bonds, and the molecular geometry is tetrahedral, and BAB angle is 109.5 degree. All the angles are equal. BAB angle it will be 109.5 degree. Examples: CH4, NH4 plus, SiF4 are examples. So all these are AB4 type. Okay. So next molecule type is AB5, in which 5 electron pairs are present. So 5 covalent bonds are there. AB, this AB and this AB. These 3 bonds are in the same plane and forming trigonal shape. And these 2 AB bonds are form 2 pyramids. So this geometry is called as trigonal bipyramidal. And angle between this BAB bond is 120 degree. That is the angle, those bonds which are in the trigonal plane. Okay, and this angle will be 90 degree with the 2 pyramids. That is AB. These 2 bonds are above and below the plane, and that form 90 degree angle. Okay, examples are PCl5 and SbCl5. Next molecule type is AB6. It contains 6 number of electron pairs. So 6 AB bonds are present, in which these 4 AB bonds, AB covalent bonds are in the same plane and form a square shape, and 2 AB are formed above and below this plane. So the shape of this molecule is octahedral, and this BAB angle is 90 degree, and with the above and below bonds also it forms an angle of 90 degree. So all the angles, all the BAB angles are 90 degree. Example is SF6. These are some of the geometry of some molecules in which the central atom contain no lone pairs. Okay, this is the first category. Now next we are discussing the second category, in which the central atom contains one or more lone pairs. Okay. Second category, central atom containing one or more lone pairs. Okay, first molecule type AB2E, where E represents the number of lone pairs. This contains 2 bond pairs and 1 lone pair. Geometry will be bend structure. Actually this is trigonal shape. Okay, but due to the presence of this lone pair, BAB angle is reduced from the trigonal angle. Okay, because lone pair of electrons occupies more space in the geometry, and the shape is bend structure, and examples are SO2, O3 and SnCl2. Next, second type is AB2E2 type. It contains 2 bond pairs and 2 lone pairs. Okay, again this is in the shape of a tetrahedral, but due to the presence of these 2 lone pairs, it occupies more space, and BAB angle is again reduced from the tetrahedral angle. Okay, distorted angles, the measure of the distorted angles with some examples we will discuss later. So this will get the bend structure. Okay, so examples are H2 and H2S. Now the third type is AB3E. It contains 3 bond pairs and 1 lone pair. This is again having a tetrahedral shape, but this lone pair occupies more space and this BAB angle is again reduced from the tetrahedral angle and the shape is trigonal pyramidal. Examples are NH3, PCl3, PH3 and H3O+. Okay. Next, fourth type is AB3E2. This type contains 3 bond pairs and 2 lone pairs and the molecular geometry is T-shape. Okay, actually this shape is like trigonal bipyramidal. But due to the presence of 2 lone pairs, this angle gets distorted. Okay, and this occupies more space in the geometry and the shape gets distorted from the trigonal bipyramidal structure and gets converted into T-shape. Example is ClF3. Next type is AB4E type. Here it contains 4 bond pairs and 1 lone pair. Okay, so it contains a lone pair here and there are 4 AB bonds are present. Here also this lone pair occupies more space in the geometry and this angle gets distorted and angle is decreased from the original trigonal bipyramidal angle. Okay, this shape is like trigonal bipyramidal but angle gets distorted due to the presence of this lone pair and the shape is seesaw. Example is SF4. Next, the molecular type is AB4E2. It contains 4 bond pairs and 2 lone pairs and the molecular geometry is like an octahedral geometry. But due to the presence of these 2 lone pairs, these occupy more space in the geometry and the angle gets distorted or the geometry is distorted and the molecular geometry of this compound is square planar. Example XCF4. Next type is AB5E. It contains 5 bond pairs and 1 lone pair. Okay. Here the geometry is just like octahedral geometry but it contains 1 lone pair which occupies more space and the shape gets distorted into a square pyramidal shape. Okay. So the geometry is square pyramidal. Examples are BRF5, IF5. Okay. So in order to find the geometry of the molecules, first we have to find the central atom. The central atom containing bond pairs and lone pairs we have to calculate, from which we can easily find the geometry of that molecule. Okay, these are the different geometry of molecules in the case of VSEPR theory.